for this session so far, we're on the right track. We're on the good track of the time monitoring. But just because the previous student post session used the 6 minutes of hours, so I have to keep everyone, every presenter to stick to your 20 minutes. Okay, our next presenter is Balamungan again. Please go ahead to share your presentation, and also with please give also a brief self-introduction. Thank you.
Can you see? Okay.
Yes.
My name is Balamungan Subramanian. I am from chemistry department from Louisiana State University. I did my PhD in chemistry, and I worked in like surface chemistry, synthesis, and catalysis. So today I'm presenting my results in the area of my work in the area of catalytic regeneration of reclaimed asphalt binder. I'm just giving this one is based mostly on chemistry. It's very high on chemistry and less on engineering. I'm just giving. So as most of you probably know, what is I call the return of a binder or payment. So after if you put the road, after some time the property of asphalt will deteriorate and the roads will start breaking down. So this is due to the hardening of asphalt binder, and the process we call asphalt aging. At this stage, the road needs to be repaired or replaced. If it is replaced, the removed pavement is called reclaimed asphalt binder. As you probably know, that asphalt is a colloidal system containing different kind of molecules. So the properties of asphalt is due to the balance percentage of different composition in a particular way, so that the property of asphalt binder will be balanced. Due to aging, and some of the molecules will undergo chemical transformation, particularly oxidation. So this oxidation introduces some polar functional groups in the molecules. So due to that, the interaction between the molecules will change. So it will undergo more aggregation. So because of that, it become more harder. So actually, before that, a lot of other people try to use a percentage of wrap binder with the virgin binder for the road pavement. So people used different techniques called, some of them use softening agent or rejuvenator, which are kind of different kind of oils. So that is to reduce the viscosity of the binder. So here my work, we concentrate on to reverse some of the chemical changes happening in the wrap binder, so that it can be used more. We can use more percentage of wrap binder. So we want to chemically reverse the changes happening during aging. So for that we use Lewis acid catalyst to reverse some of the chemical transformation. Particularly, we want to reduce the amount of oxidation as well as amount of aggregation in the sample. So I think it's too much chemistry, but when you normally asphalt, they are separated into 4 different kind of fractions. First is a saturate. Then when you go from left to right, it is mostly aliphatic, then it's aromatic, and increasingly it becomes high molecular weight. So people study the relative reactivity of atmospheric oxygen into different fractions. And when you go from left to right, the reactivity of these molecules to oxygen increases. So most of the reactions or most of the oxidation occurs during aging is due to high molecular weight fraction. So why we want to use Lewis acid is for this particular work is because in literature, Lewis acid people are used for liquefaction of coal, and also it is known that like Lewis acid, like iron chloride, can be able to dismantle the self-assembly aggregates of polar groups like oxygen, nitrogen. So we thought it will be a good idea to use iron chloride and see what happens. So as a first step, we take the wrap and we use this instrument and to get the wrap binder. So we use a trichloroethylene as a solvent to remove the binder. And particularly, I use two instruments. One is called gel permeation chromatography or size exposure chromatography, which which will be useful for determining the molecular weight distribution in the sample. Another one is IR spectroscopy. IR spectroscopy, we can see different functional groups. Here we are interested in carbonyl group. So I think, I don't know, most of the people, whether they are familiar with GPC or not, I'm just to give you a very brief explanation about GPC. In the heart of the GPC instrument, there is it is packed with a gel or a polystyrene, cross-linked polystyrene gel. It has different pore size. So when you inject a sample containing a lot of different molecules, when you put the any molecule in the solution, it occupies certain, it has certain size. So big molecule will not fit into the pores and it will come out. So progressively, so it will come out first, and progressively small molecule will come out last. So when this is a typical GPC chromatogram, chromatogram we can draw in terms of elution volume, or you can use some polystyrene standard, then converted volume to molecular weight. So this is a typical virgin binder, the red one, and this is a wrap binder. So we can typically see wrap binder have, this is high molecular weight and this is low molecular weight. So we can see the wrap binder has a lot of high molecular weight component compared to a virgin binder. So our idea is to reduce this to the extent possible. And for IR, this is the IR spectra of the virgin binder, in this case PG6722, and this is a wrap binder. So when you see that this peak is due to the polar carbonyl group is absent in virgin asphalt. And in the literature, people normally use a carbonyl index value, which is the area under the curve, under the CO peak versus under the carbon hydrogen peak. So the first step, we take the wrap binder, add different amount of iron chloride, and we kept the temperature and time constant 165 degrees for 30 minutes, and we measure the carbon index, and we, as you can see, the carbon index is decreasing to the point, but if you increase too much, so it's all again increases. So we keep that into 2%, and then we change the time. So we keep the iron chloride concentration to maximum 2% and we change the time. And okay, this is a typical GPC chromatogram I'll get. This is the virgin asphalt binder. This is a wrap binder. So we can get a lot of high molecular weight component. And normally we'll separate into three sizes. We converted to into three slices. So normally we discuss area under the curve up to this, up to 3,000 molecular weight, then 3,000 to 19,000 molecular weight, then above 19,000 molecular weight. So, and we are looking for the reduction in the area, percentage area of high molecular weight component after the treatment. So this is the value for 30 minutes at different iron chloride concentration, and the first peak is due to molecules up to 3,000 molecular weight, then again 3 to 19,000, another is 19,000, and you can see the high molecular weight fraction progressively decreasing. The low molecular weight is progressively increasing because it's the relative one. and the middle molecular weight is not decreasing a little bit, and which is what we want to do. So and this is for same result for 1 hour, and we can see again a similar trend. It's decreasing, slight increasing, it's close to same, which is again we saw the same result, same trend, not same trend for 2 hours as well as 4 hours. So when I just summarizing all the results I showed in the 4 graphs. So what we can see is the time is not very important. 30 minutes giving almost same result as 4 hours. So we can, in every case, but the percentage of iron chloride make a big difference. So in this GPC as well as IR result shows that, for example, we can visually see this is the control. Control is nothing but a wrap binder just heated at 165 degrees for 4 hours. So when you treat with iron chloride, the high molecular weight component is progressively decreasing. So by chemical analysis, I can say that we can reverse some of the chemical transformation happen during binding, move towards the virgin binder. So, but we don't know the actual mechanism, chemical mechanism up to now. We need to next step is to try to do some NMR and other techniques to see chemically what happened. So our next step is to compare the rheological properties of wrap binder with after treatment, before treatment, and this work is under progress. And we are expecting the rheological properties should reflect our chemical analysis result. We are expecting it to improvement after iron chloride treatment, but still this work is in progress. And once we got the improved property, to confirm improved properties, then we need to combine virgin asphalt with the treated wrap binder at different ratio and see what is the maximum amount of iron chloride wrap binder can be incorporated virgin binder with the satisfactory property. That's it. Thank you.